In this lesson, we want to talk about finding the collinear points using determinants. What is the collinear point? When two or more points lie together at the same line, they are collinear. As we know, we can use determinants to calculate the area of the triangle given by three vertices of the triangle. Before we further ado, I just want to review the formula because we are going to use it here. So, the area is equal to plus or minus 1 over 2 times the determinant of the 3 by 3 matrix, where x1 and y1 represent the first point, x2 and y2 represent the second point, and x3 and y3 represent the third point. We have the plus or minus here, so if the determinant becomes negative, we just multiply by the negative 1 over 2 and if positive, multiply by positive 1 over 2, and you are good to go. So, what we do if this formula gives us a result of 0, meaning there's absolutely no area? Well, it turned out that if you have this kind of 3 points that you're given, they're supposed to be a vertices of triangle, and you plug it into this formula and you get 0, those 3 points absolutely lie on the same line. Right, so those 3 points are collinear. Okay, we can kind of simplify this formula and say that if this part right here evaluates to 0, then we know those 3 points that we have are collinear. So let's go ahead and use this real quick and look at the example. We're given these 3 points here. We just want to test for the collinearity. We have 4, 1 for the first point, -1 and -2 for the second point, and -6 and -5 for the third point. Do they lie on the same line? Let's just say this 4, 1 is x1 and y1, -1 and -2 is x2 and y2, and -6 and -5 are x3 and y3. It does not matter which gets labeled as which. Then copy all the points to the formula. The third column of this matrix is all ones and everything else goes in order. What's the quick way to find the determinant? Again, what we want to do is copy the first two columns here. We want to multiply down 4 times -2 times -1, which is equal to -8. 1 times 1 times -6 equal to -6. And 1 times -1 times -5 equal to 5. And then -8 plus -6 plus 5 will give you a -9. Then we multiply up. -6 times -2 times 1 equal to 12. -5 times 1 times 4 equal to -20. And 1 times -1 times 1 equal to -1. And then 12 plus -20 plus -1 will give you -9. So, you see that what we have here is a -9 minus with -9 and will give you -9 plus 9, which is equal to 0. So because of this 0, with those kind of 3 vertices that you were given that are supposed to represent a triangle, give you an area of 0, you know that those 3 points lie on the same line, so they are collinear points. So let's take a look at the example graph here that show those 3 points are lying on the same line. Let's take a look at another example. So now we have 3, 7 for the first point, 5, 10 for the second point, and 6, 6 for the third point. Then again, let's plug these 3 points to the formula. Copy the first 2 columns, and then we're good to go. And multiply down. 3 times 10 times 1 equal to 30. 7 times 1 times 6 equal to 42. And 1 times 5 times 6 is equal to 30. 30 plus 42 and plus 30 will give you 102. Then again, we multiply up. 6 times 10 times 1 equal to 60. 6 times 1 times 3 equal to 18. And 1 times 5 times 7 is equal to 35. So 60 plus 18 plus 35 will give you a 113. So at this point, we can stop. We don't even need to do this calculation that we know it's not equal to 0, even though the result will give negative 11, which is not 0. So these points are not collinear. All right. Let's take a look at the graph that show those 3 points are not collinear, which will give you a triangle.
Today we will learn about cofactor matrix. What is cofactor matrix? The cofactor matrix is the cofactor of an element in a matrix. It is determined by the minor of that element, which is essentially the determinant of the submatrix obtained by removing the row and column containing the element in question. What is minor? The matrix formed by combining all the minor is called the minor matrix. For example, minor of the element A1 matrix here we can see is calculated as M11 det 5, 6, 8 and 9. So 5 times 9 equal 45, 6 times 8 equal 48. And then M11 equal to minus 3. If we denote the cofactor using Cij, then the cofactor of any element for Cij equal Mij times minus 1 power I plus j. I is the number of rows for the element under consideration, j is the number of columns for the element under consideration, and Mij is the minor of the element in the row I and column j. How to find cofactor of matrix. Let us understand how to find a cofactor matrix using an example. Here is the example of cofactor matrix, as you can see. Step 1. We need to find the minor of each element of the matrix. M11 equal determinant of 5, 6, 8, 9. M11 equals 5 times 9 minus 6 times 8. And then we get the answer M11, which is negative 3. Similarly, the minor of element A12 is calculated by eliminating row 1 and row 2 and taking the determinant of the remaining matrix as follows. M12 equals 4 times 9 minus 6 times 7. And M12 equals negative 6. Similarly, calculate the minor of all elements to obtain the following minor matrix, like down below. Step 2. Multiply each element of the minor matrix by negative 1 I plus j to get the cofactor of that element, i.e. Cij. So the C1 equal M1, which is M1 equal to negative 3. And then cofactor of M12 equals 6. Similarly, calculate the other cofactor to obtain the following cofactor matrix, which is here down below. Application of cofactor in matrix. Cofactor of the matrix is used to find the adjoint of the matrix, used in the calculation of determinant of the matrix, and to find the inverse of the matrix. Thank you.